Assalamualaikum warahmatullahi wabarakatuh. Okay, today for today's class, we will continue to discuss about chapter number 2, part number 2. Okay. Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Allahumma salli ala Muhammad al Muhammad. Okay, for today's class, we will continue to discuss about chapter number 2, part number 2. Okay, let me share this slide first. Bismillah. Okay, we continue with this slide. So actually, in terms of content of this slide, we already discussed in previous class, where we discussed about TNB electricity bill component, which is consists of numbers of TNB bill charges. For example, the power factor, maximum demand, ICPT, which is imbalance cost pass-through, renewable energy fund or KWTDB, which is referred to the kumpulan wang tenaga boleh baharu, which is 1.6%, and also the peak and also off-peak rates. Okay. And for today also, we still continue about the bill component, but we have another type of charges. The other charges, such as CLC. CLC stands for connected load charges, where this charge actually refer to the charge for electrical equipment connected to a system. And then we will have 1% late payment. Also, we have welding equipment charge, because this type of equipment will use large power surge when operating. And also we have temporary supply, where this charge apply for providing electricity for short-term or temporary needs. So later on we will go detail about each individual charges. So the main electricity charge that we obtain in our bill actually is the combination of capacity charges, which is referred to the maximum demand in kilowatt, where this charge only for medium voltage and also high voltage customer only. Plus energy charge, the other type of energy charges in kilowatt hours for all customers. Okay. However, we also will have 10% discount, especially for the organization that involve with charity, education, and also worship. Okay. So these are called the component charges involved in our TNB electricity bill. Okay, next. Okay, this is some sort of like example for what we call electricity bill for the domestic consumer. Okay, so actually suppose this is the familiar electricity bill. Okay, for the residential for the residential, for the household. Okay, so I will explain what call on the few parameter or few aspect that you need to know about the bills. Okay, first we have tariff type. For this case is tariff type A for the residential. Normally, this tariff A we refer as the domestic tariff. So we already discussed about the what call the band of the what call power consumption for this type of tariff. So we have tariff block that shows the what call the amount what call the range of the power usage and also the rate of the electricity that we need to pay. Okay, we have a rate RM per kilowatt hour. Okay, the amount of electricity usage, we have amount in terms of RM, so we need to multiply the what we call the amount of energy usage multiply with the rate in the tariff block, so you will get total amount of usage in terms of ringgit Malaysia. Okay, so we also will have overall energy consumption in kilowatt hour unit, total amount in terms of RM. Okay, next we will have few columns involved with service tax. ST stand for service tax. Okay, service tax ST non-applicable means what we call the energy consumption that not need to we call pay the tax. Okay, the next column is referred to service tax applicable, which means whatever value for the energy consumption here, we need to pay the tax for the service. Okay. Also, we have the charge in terms of RE fund, referred to Renewable Energy Fund, or in Malay we call KWTBB, and the percentage of charges for this type of charge is 1.6%. And we have total current charge after consider all the charges that implemented by the TNB. Okay. Also in the bill shows the outstanding charges, current charge, total bill, and the amount that we need to pay at that particular month. Okay, so these are the what we call the parameter or the things that you need to know in your electricity bill. Okay, next is the example under category ordinary power consumer. Okay, so this is a what I call the online bill. So in this bill, also we have information about the tariff block in kilowatt hours, the rate, the usage in terms of electricity, and the amount in terms of ringgit Malaysia after we calculate, multiply the amount of usage in terms of energy multiply with the rate of the electricity. Okay, so if you look at the value of called the rate and also the tariff block, so this bill actually the bill for the tariff B, which is referred to the low voltage commercial. Okay, so we have also the total usage in terms of kilowatt hours and the total amount of ringgit Malaysia that we need to pay. Okay, before we consider different type of charges. The second table shows the numbers of charges that involve. So we have current monthly charge. Okay, after reduction of discount 10% for the rangsangan ekonomi. And then also we have a renewable fund. So but for this case, 1.6% from the what we call the energy consumption, total energy consumption, or in Malaysia. So we get 17.17 ringgit 20 cents. Also, we have surcharge for late payment, around 1%. Okay, so in total, after we add all the charges, okay, including the service tax if applicable, so we get the total amount of payable 1,108 ringgit 82 cents. Okay, so this is another type of electricity bill. Also, we have electricity bill for large power consumer. Okay, here the difference. If you look at the first table, we will have the information in terms of peak usage, off-peak usage, and also the maximum demand MD in kilowatt hours. So if you look at the value in terms of rate and also the maximum demand, So this bill actually specific for tariff C1 for medium voltage general commercial, and we will have greater amount of total amount payable because this will involve the commercial activities. Okay, so this will also include the renewable energy fund, the what called the charge for the what called the maximum demand, the charge for the peak and also off peak usage, and so on. Okay, sample of electricity bill for the commercial. Okay, so this one also for the commercial. So if you look at this electricity bill, you will have the total amount payable, number 5, number 7, current charge, number 9, total bill, 14, service tax for the non, which is service tax as the non-applicable, service tax applicable, current month usage, RE fund, ICPT. So now if you compare to the previous sample, for this bill we will have the value of ICPT. Okay. RN 0.0136. And also we have the row for the late payment surcharge and the current charge. Okay. And the second part of the bill, we will have information in terms of tariff block, consumption, and also the rate of the electricity. And if we compare the rate of electricity with tariff that we have learned before, so this bill actually refers to tariff B for low voltage commercial. Okay, 29, the amount that we need to pay. 30, the current usage charge. Okay, 36, the consumption trend graph. So for this bill, we will have the trend of the electric usage for the few months, okay, for 6 months. Okay, so that's the example in terms of electricity bill for different type of tariff. Okay, now we look at what the meaning of the base load demand. So base load demand actually refer to the electrical power generated consistently to satisfy. So the base load demand refer to electrical power generated consistently to satisfy the minimum demand on an electrical grid over 24 hours. So base load demand refer to the minimum demand on an electrical grid over 24 hours. Okay. So this base load demand produced to handle a specific amount of power and is determined by the load duration curve of the grid. So we need to refer certain graph in order to determine the value of the base load demand. Typically, the base load power is usually 30 to 40% of the maximum load, sometimes also known as night load in a facility. Okay, so this is the load duration curve or profile that represent in terms of a parameter that involved will be the demand in kilowatt hours. So these are the profile that we obtain for normally within what call, for example, here for 24 hours and so on. So base load in terms of equation will be equal to 30 to 40% multiplied by maximum load. So from the curve or from the graph, we need to determine the maximum load obtained. So here, if you refer to the graph, the maximum load is around 1,800 kilowatt hours. So from that value, let's say we take 40%, 40% multiplied by 1,800 kilowatt hours. So we get 720 kilowatt hours. So the value, this value actually the base load value, the minimum demand on an electrical grid over 24 hours. Okay, so that's the meaning of base load demand. And then we go to the what I call the meaning of maximum demand, MD. So normally the maximum demand actually refer to the user that use the medium voltage and also high voltage. So in terms of definition, maximum demand refer to the highest level of electrical demand in kilowatt in a particular period, normally in a month. So maximum demand for any month approximately twice the large number of kilowatt hours supplied during any consecutive 30 minutes. Okay, so MD for any month is approximately twice the largest number of kilowatt hour supplied during any consecutive 30 minutes. So what the meaning of twice the largest number of kilowatt hours? So if we look at this graph, so we have kilowatt hours versus hour. So this is called the value of kilowatt hour within 1 month. So we need to identify which one is the highest level in terms of electrical demand in the graph. Okay, so this is the highest level of electrical demand for that particular month within 30 minutes. So this value we consider as the highest kilowatt hours reading in consecutive 30 minutes. Okay, from that graph, so we will get the highest reading, which is represented by Z value. So from this value, we can determine the value of MD, where MD equal to Z divided by 30 minutes. If we change 30 minutes into hours, so MD equal to Z divided by 0.5, and we will get 2 times Z kilowatt. MD equal to 2 times Z kilowatt. So this equation proves that MD for any month approximately twice the largest number of kWh, which means twice the value of Z. Okay, so maximum demand charge. Why can be charged in terms of for the maximum demand? First, because the TMB need to make sure sufficient electricity generation, transmission, and distribution capacity to meet the highest demand. Okay, and this kind of charge is designed to encourage customer to control their electricity demand at daytime peaks. So these are why the TMB charge for the maximum demand. How to calculate? In order to calculate the what we call the maximum demand charge, the amount charged for the MD, maximum demand, based on the recorded MD in kilowatt. So we already shows the formula how to determine MD in kilowatt, which is equal to 2Z, and then multiplied by the respective MD rate that determined by the TMB. So we will get the value of the amount charged based on the maximum demand. How to exclude? Can we exclude this type of charge? So based on TMB, according to TMB, waiving MD, maximum demand charge, will result in very high energy rate and does not encourage customer to use electricity efficiently. So which means if our company or involved with maximum demand, so we will not get discount involved with we will not get discount for the maximum demand charge. Okay, based on this statement. The step to reduce the maximum demand charge. So we have numbers of steps that can be implemented in order to minimize the maximum demand charge. First, we can practicing demand side management, which means For example, we can shifting peak operation. Whatever operation during the peak period, we can change to the activities to the off-peak period time. Okay? So the rate for the electricity at that period of time will be reduced. So we need to aware about the promotional scheme offered by TNB related to maximum demand. For example, OPTR. So we discuss about OPTR later on. Okay, so we can start equipment in stages, or we can start the equipment during the off-peak period in order to reduce the charge. Also, we can use specific controller to control the maximum demand value. We can start and stop any kind of load at specific period, especially try to start during the off-peak and try to stop the load or the machine during the peak period. And the last one, limiting the total installation maximum demand to a predetermined value. So we can try to estimate the maximum demand value, okay, before we select certain tariff and so on. Okay, how to calculate MD charge? So MD charge, the amount charged to customer is based on the recorded MD in kilowatt multiplied by the respective MD rate. Okay, for example, let's say we take our calculation based on the tariff C2. So this is the table for tariff C2 for the medium voltage peak of peak commercial. Let's say MD per month is equal to 100 kilowatt. Rate for each kilowatt of MD per month, which is referred to the peak period, MD rate equal to, if you refer to the table, equal to RM 45.10 per kilowatt. So we just, in order to get the charge, we just need to multiply the value. So amount payable, which is referred to the maximum demand charge, equal to 100 kilowatt multiplied by RM 45.10 per kilowatt. So we'll get the charge for MD is equal to RM 4,510 ringgit. So this is how we calculate the MD charge. Connected load charge, CLC. So CLC actually refers to the charge on electrical equipment charge on electrical equipment connected to a system. So in terms of definition, connected load actually is the sum of the rate capacities in kilowatt or kilo VA, kVA of all electrical devices connected to the power system within a facility. So that's the definition of connected load. So this charge applicable for the first 6 years from the date of supply connected. Customer must achieve at least 70% of its declared maximum demand, MD. And this charge actually to mitigate risk on non-utilization of asset capacity made available to customer based on their declared load requirement, which is not recoverable from tariff for the above period only. The penalty of RM 8 ringgit 50 cent per kilowatt will be charged for every kilowatt shortfall between the actual MD, maximum demand, used compared to the reference MD, RM. Okay, reference maximum demand. Okay, so this is about the CLC charge or connected load charge. And in the bill, also we have Renewable Energy Fund, or we call Kumpulan Wang Tenaga Boleh Baru, KWTB. So this charge collected through a surcharge of consumer electricity consumption at the rate of 1.6%. So the rate for this charge is 1.6%. TNB is only the collecting agent of the fund for the government. So which means the charge will go to the government. Okay, so the money that obtained from RE fund actually will go to the government. So this kind of charge also try to promote growth of electricity generation from renewable energy source. And this charge applies to all customers except domestic customer using less than 300 kilowatt hour per month. So if we use greater than 300 kilowatt per hours, 300 kilowatt hours per month. So suppose in our bill we will have RE fund charge, or we call KWTBB charge in our bill. The fund is to help sustain the natural resources in terms of fossil fuel for our future generation. Okay. One of the functions of this charge, when we use more renewable energy, so we can sustain the natural resources in terms of fossil fuel for our next future generation. And the fund is channeled to SEDA for managing and also administrating the feed system. Okay. So maybe part of the charge will go to the SEDA, the rest will go to the government. Okay, SEDA stands for Sustainable Energy Development Authority Malaysia. So this is an example of the bill that involve with RE fund or KWTBB. So if we look in the sample, so you get the row that mentioned about KWTBB 1.6%. So for this case, 14,267 and 83 cents, the amount of RE fund charge. Okay, so in the electricity bill also we'll have the row for the ICPT, imbalance cost pass-through. So in chapter 1 we already discussed about for the meaning of the ICPT. So the ICPT actually is a mechanism allowing TNB to reflect changes due to the fluctuation in fuel and also generation cost in the electricity tariff every 6 months. So before this, we already mentioned that two factors that affect the amount of bill based on ICPT. First, is the fuel cost. The second one is the generation cost. Okay, Energy Commissioner or Suruhanjaya Tenaga is the regulator determining the calculation and also the methodology of the ICPT. So this charge, ICPT charge, is a pass-through charge based on the kilowatt hour consumed per month multiplied by ICPT rate. It will either be added to or subtracted to from your current bill. So which means sometimes based on the cost of the fuel, if the fuel price increase, so we'll have added surcharge in our bill. If the fuel cost decrease, so we will have the value will be subtract from our bill, electricity bill, as we discussed before in chapter number 1. Okay, so whether the bill increase or not based on ICPT, it depend. One of the reason is it depend on the value of fuel cost. So if the fuel cost increase, so we will have extra surcharge. If the fuel cost increase, so we will get extra surcharge in our bill. But if the fuel cost decrease, so you get a rebate from the TNB. So this surcharge, ICPT surcharge or ICPT charge, applies to all customers except domestic customer using less than 300 kilowatt hour per month. Okay. So in order to prevent for this extra charge, we need try to maintain our consumption less than 300 kilowatt hours. example. Okay, so we will get, okay, I think this is from the same build. So we have ICPT. The value of ICPT is RM 0.0255. So we need to multiply the rate with the amount of energy consumed for each month. Okay, other applicable charges. Also, we have power factor PF charge, where customer must achieve a minimum power factor of 0.85 for medium voltage and low voltage level, and must achieve minimum 0.90 for high voltage level. So this one actually refer to HV, not HL. HVI voltage. So a penalty should be imposed if this minimum power factor is not achieved. So we already discussed previously how to calculate the PV charge. Also, we have late payment penalty, the surcharge of 1% per month if we late to pay the bill. Customers who fail to pay their current bill in full within the stipulated time frame will be charged 1% per month. Okay, also we have surcharge for temporary supply. So this charge apply for providing electricity for short-term or temporary needs. For example, for the construction project, so TNB supply, temporary supply in terms of electricity for the construction project, event, fairs, and so on. So charge at the tariff rate appropriate to the category plus 33% surcharge on the monthly bill. So 30% surcharge will be implemented for the temporary supply. Okay, next, the improvement for the incoming electrical energy. Okay, so based on the electrical system, for the electrical system, based on the conventional design practices that do not consider energy efficiency. So previously, if we base on the what I call the design of the electrical system in previous years, so they do not consider any energy efficiency. So the factor to consider are wiring system requirement, energy efficient equipment, and also the power supply condition. So the other factors that involve are the fixed technical losses, variable losses. We need to know the proper load management and also load balancing. We need to have good maintenance practices, and also we need to replace any faulty components in our electrical system in order to improve the electrical energy in our system. Okay, about the power quality. So in these figures, we have numbers of voltage waveform quality, magnitude, unbalanced, harmonic flickers. So here we discuss about the harmonic effect of the power quality. So due to the harmonic effect, we will get the transformer in our electrical system will be overheating. We will have excessive neutral current. We will get the damage to sensitive electronic equipment, tripping of circuit breakers, low system efficiency, poor power factor, and interference with nearby communication system. So in order to prevent this effect, which is referred to the mitigation, we can use passive or active filter. We can use power conditioning equipment, any equipment that can be used to minimize the harmonic effect, such as UPS, inverters, voltage regulators, motor generators, isolation transformer, and also the surge, suppressors. Okay, so these are in order to obtain higher quality of power. And we have also another type of approach that we later on will discuss in detail. We also will have the called thermal energy storage system (TES), and also the top up and standby tariff for the co-generators. Okay, still under improvement for the incoming electricity energy, so we can use the thermal energy storage system (TES). So this system will be cost effective when the utility rate has higher demand charges or higher differential between on and off-peak energy rates. An existing cooling system is being expanded or in the development of new buildings. Limited electric power supply is available at site. Backup cooling capacity is desirable. And for TES, consumer will enjoy higher discount for off-peak electricity. So for example, chilled water produced from the ice thermal storage system as shown in the figures. So we will not go into detail for every component. So for offers building owners, the potential for operating cost saving by using off-peak electricity to produce chilled water or ice for cooling their building during the peak hours. Okay, try to save the energy if you want to use the system during the peak hours. Okay, so this system will cut operating costs and will reduce capital outlay when systems are suitable designed for new commercial and also industrial buildings. Okay, still under the improvement, top up and standby tariff for the co-generators. So for standby charge for the co-generator will be reduced to encourage, okay, standby charge for co-generators will be reduced to encourage green technology, energy efficient, and also demand side management (DSM) initiative. So this is the schematic diagram for the co-generators, where the system will combine what I call the usage of steam, hot steam for cooling, heating, and so on. So the system will manipulate the heat release from the turbine in order to produce heating system or cooling system. Okay. So the co-generator will manipulate the heat that released from turbine to manipulate and also to use the heat for the other type of system. Top up and standby tariff apply to the co-generator utilizing a single primary energy source to generate sequentially two different forms of useful energy for its own use. Service offered to by the utility company. Okay, service offered to by the utility company, such as top-up supply required by a co-generator who does not produce sufficient electricity for its own use. Standby supply, which is provide to a co-generator. Okay, again, this component actually refer to the service offered to by the utility company. First, the top-up supply, which is referred to the supply required by a co-generator who does not produce sufficient electricity for its own use. Standby supply, which is referred to the utility company which provide to a co-generator in the event that the co-generator does not generate electricity due to plant failure or plant shutdown for maintenance. Firm standby option and guaranteed the supply. Non-firm standby will not. We will have refer to the non-guaranteed supply. Okay, so these are the about the co-generators that related to the tariff that involve this co-generator. Okay, other applicable rebate. So we have off-peak tariff rider, OPTR. OPTR is offered to all medium voltage commercial and also industrial customers who are currently not enjoy any off-peak usage tariff rates. For example, under tariff C1 for medium voltage general commercial, tariff E1, the medium voltage the general industrial, and tariff E1S, medium voltage special industrial. A 20% discount on electricity usage during off-peak hours, 10 p.m. to 8 a.m. every day. So this is under the criteria for the OPTR. Eligibility, who will get this kind of benefit? So the customer that will get the OPTR is referred to the TNB customer under C1, E1, and also OS E1S tariff, as I mentioned before. Reserving electricity supply from TNB for at least 6 months. So this is the criteria that allow the customer to obtain the off-peak tariff rider. Latest load factor is higher than the average load factor over 6 months prior to application, where load factor refers to the ratio of the average energy consumption in kilowatt hour for a certain period to the maximum peak requirement for a similar period. So these are the definition of the load factor. So the latest load factor must higher than the average load factor over 6 months prior to the application in order to use the OPTR. Okay, so load factor equal to total energy consumption divided by MD, which is multiplied with MD multiplied with total hours. No outstanding amount more than the total deposit bank guaranteed paid. Otherwise, this outstanding amount must be settled before applying. So no outstanding amount in order to apply the off-peak tariff rider. And another one, we have the Sunday tariff rider, STR. So STR is offered to all MV, medium voltage commercial and also industrial customer. Customer still pay the same rate on electricity usage. However, MD, maximum demand charges, are not applied to any electricity usage on Sunday. Okay, so this we call this discount applicable only on the usage of electricity on Sunday. That's why we call Sunday tariff rider, STR. Okay, I think this one is the last slide. Last slide mentioned about the conservation, conservation, also the efficiency. Want to know what the difference between conservation and also efficiency? Conservation, in terms of meaning, is a plan for avoiding the unnecessary use of natural materials such as wood, water, or fuel. And if we use this energy conservation means reduction in the amount of energy consumed in a system or by an organization through economy, waste elimination, and also rational use. However, for the efficiency, in terms of meaning, general meaning is the condition or fact of producing the result you want without waste or a particular way in which this is done. And energy efficiency refers to a result of technical, organization, or management changes made to an energy service or activity such as HVAC. HVAC stands for heating, ventilation, air conditioning, lighting, and etc., in which the energy use is reduced. So we have, under this energy efficiency, we have two components, which is referred to the efficient appliance. Okay, where this appliance operates at reduced energy consumption without diminishing its quality. And we have customer product, such as the energy efficient television, where we have less than 1 watt of power for the on standby mode. Okay, we'll use less than 1 watt of power. If we power on through the standby mode, and less higher than the usage of the energy efficient television, we will save more than 40% of energy. So we can save more than 40% of energy. So under industrial machinery, for example, energy efficient transformer. Okay, so the efficiency can be increased if we can improve the properties of the silicon steel material. We can have 50% reduction in electrical transmission and also distribution losses if we use energy efficient transformer. And under efficient building, so a conventional building typically consumes 40% of non-renewable energy source. A green building is designed and operated to reduce the overall impact of the life cycle on human health and also the environment. Okay, so this is what I call the component of energy efficient in the company or for the specific organization. So we need to consider the energy efficient so that we can save the energy, and also we can save the amount of money that we need to pay for the TNB electricity bills. Okay, so that's all for chapter number 2, part number 2. Assalamualaikum.